guys, welcome. Today we'll be talking about vector stores or vector database. So we have vector stores here, you can see in our pipeline. So what is a vector database or vector store? Vector store is a specialized database designed to efficiently store, manage and query vector embeddings. In the previous video, we learned the concept of embeddings. So basically, embeddings are high-dimensional numerical representation of either text, images, audio or any other data type. By using these embeddings, we can do similarity search, which will be very helpful in our case. We need something to store those embeddings and to do this search operation. And vector database helps in this area. So vector database, it helps in similarity searches. It also, we can store metadata with respect to each vector, and it is designed to handle billions of vector and perform searches with very low latency. Let's take an example. Let's say we have 100 Docker articles and we store that this information in a SQL database. So we'll be storing we'll be creating columns like title, author, content, data. If we have this question, find all articles by John about training dogs. So hence we are storing the information about each author. We'll be doing this filtering and we'll be able to find the relevant information from SQL database. But if I ask you this question, what should I feed my puppy? So this is, this won't fall in this kind of column. To sort this question, we need to first understand the data, the meaning of data that we have in our SQL, and we need to understand this, understand the meaning of this question, and then we'll find the data which will be in the similar, which will be semantically similar. So we cannot perform this semantic search in our SQL database, but in case of our vector database, we have the vector embeddings which represents the data in a numerical format, which captures the semantic meaning. So by using vector database, we'll be able to find answers like this: puppies need high protein diets with essential nutrients. So this is the difference between SQL database and vector store. Also, we can use any of these indexing strategies to do good quality search in less time. Now in LangChain, we have this local or in-memory vector stores, that means offline vector stores. So we have FAISS, we have Chroma DB, we have Deep Lake. We also have cloud-based vector stores. We have Pinecone, Weaviate, Quadrant, Milvus. So you can use any of this vector store. So these won't be chargeable, but I think they will charge some amount of fee if you want to use their services. We have your FAISS vector store. You can see while loading the PDF here, then we are using recursive character text splitter to create chunks. We are using OpenAI embeddings. Then we are storing all this information in a FAISS vector store, and then we are doing a similarity search here. So if we run this Python, you can see it is doing all of this thing. And you can see after doing a similarity search, we have these documents. Similarly, here we have Chroma DB. You can see same thing. We are loading the PDF. We are splitting into different chunks. We are using the OpenAI embedding here. We are creating the vector store here. We are using the Chroma DB here. Then here we are doing the similarity search. So it has loaded and you can see it has created this vector store. Query and retrieve documents, top 3 relevant documents. So here we have retrieved relevant document to our query, and then after that here we are extracting documents, embeddings and metadata. So this is the print statement for that. Document 3 and metadata. And then here we are these are for before update. So before update you can see we have this value, and then after update we have this value. So after that here we are adding the new document added. So guys, I hope this was helpful. Please do like, subscribe and share. I'll see you in the next video. Till then, take care.